Welcome, dear friends. Today we invite you on a fascinating journey beyond our world, a journey that many dream of, but few truly understand. Space exploration is one of humanity's greatest adventures, filled with hope, wonder, and incredible challenges. You might think that traveling to planets like Mars or building colonies there would be easy by now, but the truth is very different. The universe is vast and strange, and exploring it demands courage, patience, and technology we are still developing. I want you to feel valued as we explore these mysteries together, because your curiosity and wisdom make this journey even more special. If you enjoy learning about the wonders of the cosmos and want to keep receiving valuable insights that can inspire your mind and spirit, please click the subscribe button below. Your support helps us continue sharing these amazing stories with you. Also, feel free to leave a comment with a simple word that comes to your mind when you think of the universe. It can be anything powerful to you: hope, infinite, or even mystery. Your words mean a lot to us. Don't forget to like and share this video with your friends and family so more people can join our community. Throughout this video, we will explore the incredible challenges and strange surprises that make space exploration both difficult and wonderful. And near the end, I will share a very important message that I hope will inspire you deeply. So stay with us until the very last moment, because this is a story worth hearing all the way through. Let's begin by understanding why reaching and living on other planets is far more complex than most imagine, and why, despite all the progress we have made, the dream of colonizing places like Mars is still just beginning. When we look up at the night sky, it's natural to feel a sense of wonder and imagine how incredible it would be to visit other planets or even live. Many of us grew up watching stories about astronauts walking on the moon or space stations orbiting faraway worlds. These dreams inspire us, but the truth behind space travel is far more complicated and challenging than it might seem. Landing humans on the moon was an extraordinary achievement, but the moon is much closer and easier to reach than other planets. If going to the moon was like stepping off a small boat onto a nearby island, traveling to Mars or beyond is more like diving into the deep ocean without knowing what lies beneath. The distances are immense, the environment's harsh, and the dangers many. One of the biggest challenges is simply surviving the journey itself. Space is unforgiving. Extreme temperatures, deadly radiation, and the vacuum of space make every moment risky. Unlike the short 12-day Apollo missions, a trip to Mars would take almost 3 years round trip. Imagine being confined in a small spaceship for that long, far away from home and everything familiar. Then there is the problem of fuel. To slow down and safely land on another planet, spacecraft need to carry huge amounts of fuel, which adds weight and complexity. For example, landing on Mars or Mercury requires carefully planned maneuvers to avoid being pulled by the sun's strong gravity or crashing at high speed. Every calculation must be perfect, or the mission could fail. Despite these obstacles, scientists and engineers keep pushing forward. They design better technology, study planets in more detail, and plan missions with patience and precision. Each success, no matter how small, brings us one step closer to exploring new worlds and perhaps even building homes there someday. So, while it might seem like conquering other planets should be easy by now, the reality is that space exploration remains one of the most difficult challenges humanity has ever faced, but it is also one of the most inspiring. After understanding how challenging space exploration is, let's focus on one of the most difficult planets to visit, Mercury. It is the closest planet to the Sun, but don't be fooled by its proximity. Exploring Mercury is like trying to land a small drone right in the middle of a giant fire. During the day, Mercury's surface reaches scorching temperatures of up to 430 degrees Celsius, hot enough to melt lead. But at night, the temperature drops dramatically, falling to nearly minus 180 degrees Celsius. This extreme and rapid change in temperature makes the planet a nightmare for any spacecraft or rover. Imagine having to survive both a fierce furnace and a freezing cold night, all within hours. Mercury also lacks a thick atmosphere like Earth or Mars. This absence means there is no natural brake to slow down spacecraft when they approach the planet. On Earth or Mars, spacecraft use air resistance to help them reduce speed. It's like using parachutes to slow down a fast car. But on Mercury, there is no air to slow the ship down. To land safely, the spacecraft must use an enormous amount of fuel to carefully reduce its speed at exactly the right moment. To make things even more difficult, Mercury is caught in the Sun's strong gravitational pull. Any spacecraft traveling there must slow down drastically to avoid being pulled into the Sun like a car without brakes racing down a steep hill. This requires incredibly precise calculations and planning, because even a small mistake could mean the mission is lost forever. Despite these daunting challenges, scientists have not given up. They are eager to understand Mercury better because this mysterious planet holds important clues about how our solar system formed and how it might change in the future. Early missions struggled to fully explore Mercury, but over time, technology has improved, allowing us to discover surprising details about its surface and even hints of ice in its shadowed poles. Something that seemed impossible for such a hot world. Mercury shows us that space exploration is not just about distance, but also about dealing with extreme conditions and complex physics. It reminds us how much patience, skill, and innovation are needed to reach even our closest neighbors in the solar system. After learning about the challenges of Mercury, many people believe that Mars is the easiest planet to reach and even colonize. It has been called humanity's best hope for a new home beyond Earth. But the reality is much more complicated than popular stories and movies suggest. A mission to Mars would take almost 3 years round trip. That means astronauts would have to live inside a small spacecraft for a very long time, far from their families and everything familiar. They would face dangers like cosmic radiation, which Earth's atmosphere and magnetic field protect us from, but Mars cannot. This radiation can cause serious health problems over time, so protecting the crew is a huge challenge. Besides the long journey, surviving on Mars itself would be tough. The planet's surface is cold, with dust storms that can last for weeks, and harmful radiation constantly bombarding everything. Astronauts would need special shelters, life support systems, and enough supplies to last for months or even years, since returning to Earth isn't as simple as pressing a button. One of the biggest difficulties is the fuel and equipment needed for the return trip. Unlike the Moon, where the gravity is low and astronauts could easily take off, Mars has stronger gravity, meaning rockets have to be much more powerful. Building and fueling a rocket directly on Mars is a huge task that we have not yet mastered. The timing of the mission is also critical. Earth and Mars are only close enough for travel every 2 years or so. Missing this window would mean astronauts could be stuck on Mars for a very long time, waiting for the planets to align again. This adds pressure to plan carefully and build reliable technology. When we compare this to the Apollo missions, which lasted just a few days, the difference is enormous. Apollo astronauts went to the Moon, spent a short time there, and returned safely on rockets launched from the lunar surface. Mars missions require us to think on a much larger scale, with longer times, more risks, and far more complex challenges. Despite all these difficulties, the hope of reaching Mars keeps driving scientists and explorers. Each small step, each test and mission, brings us closer to understanding what it really takes to live on another world. The dream is alive, but it demands patience, courage, and incredible teamwork. While Mars captures much of our attention, the giant planets like Jupiter present challenges of a different kind. Exploring Jupiter itself is almost impossible because it is a gas giant, meaning it has no solid surface to land on. Instead, any spacecraft trying to enter Jupiter's atmosphere would face crushing pressure and extreme temperatures that would destroy it long before it could reach any stable place. Jupiter also has an incredibly strong magnetic field, creating intense radiation belts that surround the planet. These radiation levels are thousands of times stronger than what we experience on Earth, and they can quickly damage or destroy spacecraft electronics. For this reason, missions like NASA's Juno have had to build special titanium shields to protect their instruments, but even then, their time near Jupiter is limited. Yet the real hope for discovering something extraordinary lies not on Jupiter itself, but on its many moons. One of the most fascinating is Europa, which hides a vast ocean beneath its icy crust. Scientists believe this hidden ocean could harbor the conditions needed for life, making Europa one of the prime targets for future missions searching for signs of extraterrestrial life. Other large moons like Ganymede and Callisto also hold mysteries that could teach us more about the origins of the solar system and the potential for life beyond Earth. Exploring these moons is complicated, but offers a chance to study worlds very different from our own. Beyond Jupiter, Saturn's moon Titan draws attention for its thick, nitrogen-rich atmosphere and rivers and lakes of liquid methane. Titan's landscape resembles Earth's in some ways, with dunes, mountains, and weather systems, but it's also alien, with temperatures far colder than anything on Earth. The Cassini-Huygens mission gave us a glimpse of Titan's strange beauty, and future missions, including flying drones, are planned to explore this intriguing world even more closely. Exploring these giant planets and their moons requires new technologies and bold ideas. While reaching Mars is hard, venturing to the outer solar system is on another level of difficulty. But with every mission, we expand our understanding of the universe and our place within it. While Mars, Jupiter, and Saturn have been the focus of many missions, the distant ice giants Uranus and Neptune remain largely unexplored. These planets are far away, making any mission expensive and time-consuming. To put it into perspective, a spacecraft can take more than 10 years to reach them, even when using carefully planned routes. Because of their distance, Uranus and Neptune have been visited only once, by the Voyager 2 spacecraft in the 1980s. Since then, no other missions have studied them up close. This lack of exploration leaves many questions unanswered about their composition, weather, and moons. Uranus is known for its unique tilt, spinning almost on its side, which causes extreme seasons lasting over 20 years. It also has some of the fastest winds in the solar system, reaching speeds over 2,000 kilometers per hour. Neptune, with its stunning blue color, is famous for the strongest winds recorded in our solar system. Among Neptune's moons, Triton stands out. Unlike most moons, Triton orbits in the opposite direction of Neptune's rotation, suggesting it might have been a captured object from the deep space beyond the solar system. Scientists also suspect that Triton hides an ocean beneath its icy surface, which could be a key to understanding more about life beyond Earth. Because of these mysteries, many scientists believe that future space missions should focus on these forgotten planets. Exploring Uranus and Neptune could reveal new information about how our solar system formed and evolved, as well as clues about planets around other stars. However, sending missions to these distant worlds is no easy task. The long travel time, high costs, and technical difficulties make planning a mission to Uranus or Neptune a challenge that will require international cooperation and advances in space technology. Still, the potential rewards are great. As we learn more about these icy giants, we may discover new wonders and gain a better understanding of the vast and varied family of planets that share our Sun. Now that we have explored the challenges of reaching planets within our solar system, let's imagine what it would take to travel even farther beyond the Sun's influence to other stars. This is the realm of interstellar exploration, a dream that has fascinated humanity for generations but remains far from reality. The nearest star to us after the Sun is Proxima Centauri, more than 4 light-years away. To put that into perspective, even the fastest spacecraft built so far would take tens of thousands of years to reach it. For example, Voyager 1, launched in 1977, travels at about 60,000 kilometers per hour, yet it would still take nearly 76,000 years to arrive at Proxima Centauri. Clearly, with our current technology, interstellar travel is out of reach for any human lifetime. But scientists and engineers are exploring new ideas that could one day make it possible. One of the most promising concepts involves the use of laser sails, tiny, lightweight spacecraft propelled by powerful lasers from Earth. These sails could accelerate to a significant fraction of the speed of light, reducing the travel time to nearby stars to just a few decades. Projects like Breakthrough Starshot aim to develop fleets of such tiny spacecraft to send to Proxima Centauri and beyond. While these probes would be small and unmanned, they could send back the first close-up images of planets orbiting other stars, helping us learn if life might exist elsewhere in the universe. Even if these ideas succeed, the journey will still be long and difficult, and it will require generations of dedication and innovation. Until then, our focus remains on better understanding and exploring our own solar system with its many mysteries and wonders. Space exploration teaches us patience and hope. Every mission brings new knowledge, challenges old assumptions, and fuels the human spirit of discovery. The universe is vast.